Okay, Assalamualaikum and hello. So this is just a revision for your test 1. Okay, so this is the equation will come out something like this. Okay, so Z1 I think I forget I cut some of it. So this one, another one. Okay, I miss in the question. So how to do this? Okay, so I will show you one by one. Okay, let me check the recording first. Okay. So what to do first? And first one is z1 is equal to, okay, for z1 is because the question asks you to find s total, so your target is to find the s for each resistance and then you just sum it up. Okay, so how to do this? Okay, and how to do this is you can see here. Okay, remember P is equals to S multiplied by PF. Okay, if you recall back, this is the equation. So S is equals to P divided by PF. Okay, so P is 360 divided by 0.8. You get, okay, use your calculator. 360 divided by 0.8 is 450. So this one is the complex power. Okay, so this is complex power, so you have to know what is the theta. So theta, of course, theta is cos -1 PF. Okay, and because this is lagging, this is plus. Okay, if lagging is plus, leading is minus. So make sure you know that. So because this is lagging, just plus. Okay, theta is cos inverse -1 0.8. So you get, so 36.87. Okay, degree. So S complex power is equals to 450. Okay, angle 36.87 degree. So you get the S1. Okay, this is S1 and 1 1 1 1. Okay, and this one 1 1 1. Okay, how about number 2? So number 2 have voltage and current. Okay, so if you have voltage and current, you can use the formula S2 is equals to VI conjugate. Okay, so recall back the formula. Make sure you know all the formula. There are a lot of formula for power, so make sure you know all. So V is 200 angle phi multiplied by 3 angle -20. So because you see here there is conjugate here. Okay, when you have conjugate, you have to put negative. If 20 degree, it is become -20. If -20, it become +20. You have to flip it. Okay, so this one is just for current. So use your calculator to find the answer. Okay, so equals to 200 angle phi multiplied by 3 angle -20. So the answer is 600 angle -15. Okay, so you get S2. Now S3. Sorry, this is the complex power because you have angle here. So S3. So how to calculate S3? Let me, okay. So S3 you have VAR, which is Q. So you have to know, relate the unit with the what is the component. So you have Q3 is equals to 160. Okay, 160 VAR, and P3 is equals to 230 watt. So if you recall back, S is equals to, complex S is equals to P3 over 3 plus JQ3. So this one is 230 plus J160. Okay, VA. This is the unit. So you get this all, and you have to find ST is equals to S1 plus, sorry, this is complex, so make sure you use the correct symbol. So S total equals to S, okay, 1 plus S 2 plus S 3. Okay, so you just add it all. So use your calculator again. So the answer is 1169.56 plus J274, okay, 0.71. Okay, or you can use, okay, I suggest for complex power you have to use both format, okay, or 1201.38 because it has multiple information here. Angle 13.21 degree. Okay, so this is the answer for the first question, which is S total, and then find S1. So S1 is a little bit tricky. Okay, so this is a little bit tricky because, okay, not much information you have. Okay, so if you can see here, this one you have to be creative. So you can see here Z2 has the current. So if you draw this, okay, something like this, this is IS, okay, you can see here at Z2 they give current 3 angle 20, okay, and here they don't give the current. Okay, so this is, I assume this is I2, this is I1. Okay, so I1 you don't know, okay, you don't know the current, so they give you, okay, you can see here S, okay, you already calculate the S complex, okay, S complex you already have it, okay, is equals to S3 is S1 is equals to, check back, 45036 by 0 angle 36.87, but you have the resistance. So if you recall back, complex power is equals to VI, okay, conjugate, equals to V squared, okay, divided by, okay, V squared divided by Z conjugate, or equals to I squared, okay, divide multiply by Z. Okay, you have to memorize everything, so make sure you know which is the conjugate one. So you have V, you have to conjugate, and you have a square, make sure you only use magnitude. So this is the formula. So you can see here you have this one, okay, and another one is you want to find the current. So I, you have to use this one. I is equals to square root of S divided by Z, okay, but this one is only magnitude, okay, that's why it give it give the angle. So you can see here this is a angle. Okay, sorry about that, I forget to do this. So S is equals to, okay, let me, S is 450 angle, okay, 450 angle angle 36.8, okay, divided by Z is 3 plus 4J, okay, and make sure I is, don't forget you have to, okay, amplitude this, only take the real power, you cannot use the complex power. So 450 angle 36.8 divided by open bracket 3 plus 4J, okay, equals to, you have to change it to the magnitude, okay, so you get 90. Okay, let me move this. So you get 90 angle negative 16, but of course you have to magnitude this, so you get square root of 90 only. Okay, square root of 90 is equals to 9.48. This one is only the magnitude. okay, I1. Okay, so you have to insert this into here. Okay, and then so is is equal to I1 plus I2, so is is equals to 9.48 angle 11 because already given here, and then plus, okay, this one already given also 3 angle 20 degree. Okay, so is is equals to this answer. Okay, make sure you know how to interpret the data. Okay, if you have something like this, okay, if you have a circuit, given a circuit something like this, okay, for example, if you have another one something like this, okay, if they give this data, for example 300 angle 20 volt. Okay, so if the voltage, they said the voltage here is 300 angle 20, and this one also 300 angle 20 because this is in parallel. Okay, make sure you know okay, this one also the same, but for this case it is series, in series. Okay, make sure you, okay, this one in series because they give the current, you already know the current for Z2 and Z3. Okay, make sure you know how to manipulate this. Okay, so this is for question 1, focus on AC power. And now for question 2, of course, you need to know how to understand the text. Okay, let me make it bigger. And for this one, of course, okay, for question 2, the mean length of A and B is LA is equals here is 30 millimeter cm. Okay, cm is 0.3 meter. LB is equals to 10 cm, which is 0.1 meter. Okay, make sure you change it to SI unit. Okay, make sure you understand the mean length means that this is length. Okay, and the relative permeability, of course, mu r, relative r, and for A is 3000 and mu RB is 6000. Okay, and the effective area all core are area. Okay, the area is 1 cm squared, so you have to change this into 1 divided by cm is 100, don't forget to square because this is cm squared, so 1 multiplied by 10 negative 4, okay, meter squared. Okay, so the air gap L gap is equals to 4 mm equals to 0.004 cm. Okay, so n is equals to 300. Okay, make sure you know how to extract the data. Okay, if the flux density, what is flux density? Of course, this is B, and where? At the gap. Okay, so at the gap is 2 Tesla. Another way to know this, you look at the unit. Okay, T is Tesla, so Tesla is B. How much the current is needed? So for this to work, you have to calculate the, of course, you have to calculate the reluctance for all. Okay, because this is all in series, means that you just add all. Okay, so S total is just equals to core A divided by mu naught mu R A. Okay, because it said that the area, effective area, is all the same. Okay, and when it comes to, if they don't mention, means that the area at the gap also the same. Okay, they usually say that there is no fringing effect. Okay, so if there is no fringing effect, the area is remain the same. Okay, so this one, and don't forget to plus because this is in series. Okay, so you can see here this is all in series. Okay, all in series plus LB divided by mu naught mu RB A, and then plus L the gap. Okay, mu naught A. Okay, mu naught for the gap, mu R for the gap is 1. Okay, unity, so just leave it blank. So you simplify this, ST is equals to, okay, okay, 1 over mu naught a l a divided by mu r a plus l g l b divided by mu r b plus l g. Okay, this is my way because this is less. This is just to avoid error in the calculation. This is simplified. But if you want to calculate one by one, is also can. Okay, you get almost the same answer because you have depend on your decimal point. So for this, of course, you have to calculate inside the inside first. So 0.3 divided by 3000 plus 0.1 divided by 6000 plus 0.004, and then divide by shift constant universal phi. Okay, or 4 pi multiplied by 10 negative 7. Make sure you know how to obtain the mu naught. Divide by the area is 1 negative 4. Okay, so you get the S total is 332.76 multiplied by 10 negative 6. Okay, ampere turn Weber. Okay, Weber. Okay, you get the total flux, and then from B you can see here B is given here, B at the gap, because this is in series and there is no flux leakage, means that flux is equals to BA equals to BG. Okay, flux at the gap or flux for all. Okay, it's the same because this is in series. Okay, the flux is not divided. So A, okay, at the gap, which also the same, air everywhere, get area everywhere. So 2 Tesla multiplied by area is 1 E negative 1 multiplied by 10 negative 4. So flux is equals to 2 multiplied by 10 negative 4. Okay, so flux is Weber. Okay, so remember back, F is equals to Ni equals to S flux. Okay, so therefore I is equals to S flux over N. S is 32.76 multiplied by 10, 6. Okay, flux is 2 multiplied by 10 negative 4, which is this one, and then divide by number of turn is 300. Okay, that is how you solve the first question. Okay, now the second question. What happened to what is the magnetic field strength at the A gap? So you already have B for question B. You already have BG is equal to 2T. Okay, and recall back, hash is equals to B divided by mu. Okay, so because this is air, so mu equals to mu r is equal to 1, so just mu naught. Okay, B gap, hash gap. So hash gap is equals to, okay, B is 2 divided by mu naught. Okay, this is how to solve B. And how about C? If the gap is removed, okay, what is the current? So basically you have to solve the question A again, but this time ST is just equals to 1 over L A divided by mu naught mu R A plus L to LB. Okay, mu naught mu RB A. Okay, so the gap is just removed. So you calculate this. Okay, you get the answer here. Okay, C. Okay, this one. Okay, and the flux remains the same because it said that if the gap is removed, need to maintain the same flux. So you just use the same flux, you can get the current, which is smaller. Okay, and then assume that the maximum flux density. Okay, this one is a little bit confusing. Okay, maybe some of you don't know. Okay, I think already okay, I already teach you this one. Okay, recall back. So BH curve. Okay, so in theory it's something like this. It's a straight line, but actually at a certain level it is become saturated. This is called the B max. Okay, so assume that the flood density is only 1.5 T. You cannot increase it more. Okay, if you increase it more, the B flux is equals to BA, right? So A doesn't change, not change. So B doesn't change. Okay, because it's already saturated. So flux remain the same. So how to calculate the magnetic field strength in core A? So basically you just B equals to, okay, hash equals to B max divided by mu, not mu RA. That's it. Okay, so you get the answer. Because it is already saturated, you cannot increase the magnetic flux density already. Okay, it's already saturated. Okay, so this is how you try to answer the magnetic field circuit. So make sure you understand both question. Okay, that's it. Okay, good luck with your test 1. Okay, test 1 will be held next week, 29. Okay, so make sure you attend at 9 p.m. The test is 1 hour and 15 minutes. So make sure you practice punching in the number in your calculator, because it's usually take a lot of time to punch in your number. Okay, that's it. Good luck. Thank you.